do is we're going to run through the lesson pretty quick, and then I do need you guys to pull out that handout from before. We're going to finish that off too. All right? So the formula thing, I was wrong yesterday. You guys don't even know the formula for hypothesis test, but this is the one you need to know.
Are you sure?
I am 100% sure. 100% sure. Okay. So yesterday we did a hypothesis test. Today we are doing a what? What's the other thing? Confidence interval. Thank you. All right. So we're going to do a confidence interval to try to catch the true slope of the LSRL, the population's LSRL. This is the formula that you need to know. All right. This is B sub 1. What is that? B sub 1. Slope. Yeah. All right. So that's your sample slope. All right. So you have your sample, you have your data. You type that into your calculator. Your calculator will give you that slope. Okay. This we haven't done in a while. All right. This is the critical value depending on what percent confidence you are. Are you 95% confident? Are you 90% confident? So that's going to help you get this number. And then the standard error, this will be given to you in that mini tab. All right, so this will be given to you. This will be given to you. This middle one, you have to calculate. Okay. So let me show you the easy way first, and then I'll show you guys how to use this formula. All right. So let's go back to our maternal age and baby birth weight example. All right, create and interpret a 95% confidence interval for the slope of the regression line. Okay. So the first thing you do is you do your conditions. We've already done it before, so I'm not going to do it again, but do your conditions. Step 2, I will use a T-model with n minus 2 degrees of freedom. So there's 10 women here, so 8 degrees of freedom. Yeah, same. To do a linear regression T interval. All right, so same statement as yesterday, is just we're doing an interval this time. All right. Now I have all the data in my calculator already, so I'm going to show you the easy way first, which is just they give you a list of data. You type that into your calculator, and your calculator will have stat test, lin reg t int, close to the very bottom. Lin reg t int. All right, we have L1, L2, confidence level, they said 95%. So just calculate. All right, so I have 139.3 up to 29 to 351.01. So really, it's actually the last part that's a little bit trickier. It's just the interpretation of this interval. Okay? So we're going to include the idea of how we interpret slope. Right? Slope was for every increase in x of 1, the y changes by that slope. Right? Every increase of 1 in x. So we're going to include that in our interpretation. So I am 95% confident that for every increase of 1 in mother's age, all right, so this is your x variable, and I'll do increase of 1 here, in mother's age, the average change in your y variable, which is baby's weight, is between 139, or is 139.29 grams to 351.01 grams. I'll do it. And that's it. All right. So I'm 95% confident that for every increase of 1 in the x variable, the average change in the y variable is between here to there. Okay? And that's how it's done. All right. Questions on that? No, not yet. We're not doing it. You guys have to practice.
Practicing. Terrible idea.
All right. Any questions on the easy way? On the easy way.
We're gonna have to teach the hard way.
Okay. The tougher way is when you don't have the list. Okay.
Oh,
And you only have the mini tab. So grab the handout that we've been working on the past 3 lessons. We're going to do the mini tab. So the electrical usage. We have to do line again. No. Alright, so take out this one. Alright, take out this one. We did the hypothesis test already, so we're good there. We did the conditions already, so we're good there. Let me show you how to do this last part. Explain the association using a 95% confidence interval. Okay. So we already ran through the condition. Now here, how many degrees of freedom is this one? 10, right? So right here, df under residual. All right, so we got 10 degrees of freedom. Still T model. To do a linear regression T interval. Linear regression T interval. Now, this is how you do your calculation of the interval given the mini tab. Hypothesis test was really easy because we can just grab the T from here, p-value from here. Confidence interval, nowhere. Okay, so you actually have to do some calculations from there. So the formula was b sub 1 plus or minus your critical value t star times your standard error of b sub 1. The mini tab gives you 2 of these things. B sub 1 is right here. Okay. So you find constant. Right next to it is the y-intercept. Right below that is your slope. So that's your b sub 1. Right next to it is your standard error of b sub 1. So that. Okay. The only thing you guys have to calculate is the t star. Okay. So the t star. The t star comes from the fact that you're doing a 95% confidence interval. 95. Okay. So when you do a 95% confidence interval, that 95 is right in the middle of your T model. Your T star is this value right here, is those cutoffs. Okay. So, does anybody remember what function on your calculator to use?
Well, it's not 1.9%.
No, that's for normal model. This is a T model. Yeah. Does anybody remember what function on your calculator will get you this value? If you plug in the area, it gives you the T. The other one. Inverse T. Inverse T. Okay. All right. So you're going to do inverse T of the area to the left. So what's the area to the left of this line? 2.5%. Nice. So we got 0.025 degrees of freedom of 10. Inverse T, we go second. This one right here. Distribution. Number 4. Alright, so 2.228. Alright. So we have negative 50.9027 plus or minus 2.228. You can ignore the negative on that T. Times 4.98. Alright, and then you just type it in. one side and the other side. All right, so we got negative 61.998 to negative 39.807. Okay, questions on that calculation part? Okay, so from there, I'm 95% confident that for every increase of 1 degree in temperature, monthly temperature, the average change in electrical usage is between negative 61.998 kilowatts hours to negative 39.807